Let us learn more about projectile motion. So in the last video, we saw that for a projectile, which is a body which is projected at a certain angle with the horizontal, if it is projected like this, it goes down like a curve, and here in this case, this is the initial velocity, the tangent drawn to the curve at the initial point, which makes an angle theta with the horizontal, which we call as the angle of projection. And for such a projectile, the acceleration that acts on it is only in the downward direction, having a value of g, 9.8 meter per second squared, right? So a projectile motion essentially is a uniformly accelerated motion which is accelerated in the vertically downward direction. Along the horizontal, there is no acceleration. So the horizontal motion is basically a uniform motion. No change in velocity along the horizontal. Okay. We also saw that the time of flight of such a projectile comes out to be 2u sin theta by g. So from this expression, if we try to find out that value of theta for which t would be maximum, the time that the projectile takes to come back to the ground is maximum. Do we understand? T will become maximum for a given value of u, for the given initial speed. T will take maximum value when sin theta takes its maximum value. And what is the maximum value of sin theta? The maximum value of sin theta is 1 when theta is 90 degrees, pi by 2 radians, right? So do we understand what do we mean by theta being 90 degrees? How is the projectile projected in this case? Understand that theta is equal to 90 degrees means that the projectile is thrown upward, directly upward along the vertical, right? So out of all the possible cases of a projectile, this particular projectile which is thrown upward with a velocity u will take highest time to come back to the ground. Okay. Then we can similarly talk about the height expression, the maximum height, which is u squared sine squared theta by 2g. See that h will also be maximum. H is maximum when once again sin theta is maximum, right? Which is when theta is 90 degrees. So the height attained by the projectile is also maximum when you throw it vertically upward instead of making any other angle with the horizontal. The next thing that we can discuss would be about horizontal range, r, the formula for which we got in the last video as u squared sine 2 theta by g. For what value of theta would r be maximum? Just think about it. Can we say r will be maximum when sine 2 theta takes maximum value, which is 1. What does that imply? That implies that 2 theta should be equal to 90 degrees or theta should be equal to 45 degrees. So what does that imply? That implies that for a projectile which is projected with any speed u, if we wanted to cover maximum possible horizontal range, this range we want it to be maximum, for that we need to ensure that the angle of projection theta is kept as 45 degrees. So this is an important result. R is maximum and theta is 45. Okay. In fact, at this theta, what will be the value of r? Maximum range will then be u squared by g, because sine 2 theta will be 1 now, isn't it? So this is the maximum possible value of horizontal range for a given speed. We can also see one more thing. See that the range when the angle of projection is theta is u squared sine 2 theta by g. Let us find out the same range if we change the angle of projection from theta to 90 minus theta. Range corresponding to an angle of projection of 90 minus theta will be, by the same definition, u squared sine 2, instead of theta we will write 90 minus theta now, divided by g. Solving this will give us u squared into sine, let's open up the bracket to get 180 minus theta, 180 minus 2 theta actually, divided by g. And what is sine of 180 minus 2 theta? We know that from how sine behaves, sine of 180 minus any angle is sine of that angle itself. So, we can write this as u squared sine 2 theta by g. Isn't it so? What do we see? We see that the range for an angle of projection 90 minus theta is coming out to be the same as the range for an angle theta. See, it is the same as this value. So, what we get from here is that the range of a projectile for an angle of projection 90 minus theta is equal to the horizontal range for angle of projection theta, given the initial speeds are the same, which is another important result. You get direct questions based upon this. What are these two angles, theta and 90 minus theta? See that these are angles which are complementary. When we add them, they give us a sum of 90 degrees. Such angles are called complementary angles. So, we say that range, horizontal range for complementary angles is always equal. Okay. The next thing, for a projectile, we have already seen that the velocity along the x direction, which was given by ux plus ax into t using the first equation of motion along the x axis, because ax is 0, there is no acceleration along the horizontal, this becomes equal to ux itself, initial velocity along the x direction, which if you remember, we proved it to be u cos theta. In the last video itself, we studied projectile. Vx is equal to u cos theta and it remains constant throughout. So, at any point in time, the velocity along the x direction will be u cos theta. Similarly, along the y direction, the velocity of the projectile at any time will be uy plus ay into t. Along the y direction, it is u sin theta, and ay, the acceleration along the y direction, is minus g along the downward direction, right. So, this is the velocity component along the y direction at any time t. From these two expressions, can we find the total, the net velocity of the projectile at any time t? Can we say velocity vector at any point in time can be written as Vx I cap plus Vy j cap? This comes from our information of vectors, right? So, we can substitute the values of Vx and Vy here. It will be u cos theta I cap plus u sin theta minus gt j cap. This is the velocity vector of the projectile at any time t. Whatever value of time you put here, you will get the corresponding velocity of the projectile, right. From here now, see that we can find out more information. We can find out the magnitude of this velocity vector. What is the magnitude? It will be square root of Vx squared plus Vy squared by the definition of finding the magnitude of a vector. From here, we can just solve this, right? We can just substitute these values and solve them to get the magnitude of velocity. It will take a little bit of mathematics for you to get the final answer here, right. We can also get the direction of this velocity vector. So, just to get an idea, let me just draw the figure here. So, this is, let us say, our Cartesian system, the plane along which the projectile moves. The projectile starts from the origin, it moves up and then it moves back down, and we know that the velocity at any point in time is given by the tangent vector drawn to the curve, right. Understand that this velocity vector at any point in time will make a certain angle with the horizontal as well as the vertical. We can call it the angle phi, because theta we are already using for the initial angle of projection, right. That theta keeps on changing, no, as the velocity progresses, the angle that the velocity makes with the horizontal keeps on changing. So, do we see from here that if your velocity vector at any point in time is, let us say, pointing like this, this is the x direction and this is the y direction. So, its components along the x and the y directions, we can use them to find out this angle phi using trigonometry, right. Can we say from this figure tan phi is equal to the opposite Vy by the base Vx. So, that is how we can find out the angle that the velocity vector makes with the horizontal. We can substitute the values here. We know that Vy is u sin theta minus gt, whereas Vx is u cos theta, isn't it? So, this expression gives us the direction of the velocity vector as well. So we can, in that sense, we can get the complete information about the projectile's velocity at any point in time, right? So these are a few more things that we can get to understand about a projectile, the limiting values of time of flight, horizontal range and height, then some information about the horizontal range, when is it maximum, when is it equal. So we understand that for complementary angles the range is equal, and then getting the velocity of the projectile at any time t. Let us now take up a few examples from projectile to acquaint ourselves more with the topic. So the first example is, let's say a ball is thrown with a speed of 30 meters per second, making an angle of 30 degrees with the horizontal. So the angle of projection is 30 degrees. Okay. So in this case now we are supposed to find out, number 1, the range of the projectile, number 2, the height of the projectile, and number 3, the time at which the projectile reaches the highest point t, when projectile reaches the highest point. So how do we go about it? For finding out the range, we can use the direct formula. The range r is u squared sine 2 theta by g. We can substitute the values here. U is given to us as 30, so 30 squared sine 2 theta means sine 60, which will be root 3 by 2, and divided by g. We can take the value of g as 10 here. It is mentioned that we can take g as 10 meter per second squared. Now the next thing is, we just have to solve this, right? What remains now is just to solve it. When we solve it, we shall see that, okay, this 290 root 3 by 2, which divided by 2 will be 45 root 3 by 2, not 45 root 3 only. Yeah, so this is the answer for horizontal range. Now we come to the next part of the question, which is the maximum height attained by the projectile, for which we again have a formula, u squared sine squared theta by 2g. Direct formula, we can substitute the values and get our answer. U squared is once again 30 squared into sine squared theta, which is sine squared 30. Sine 30 is 1 by 2, so it will be 1 by 2 whole squared, 1 by 4, divided by 2g, 2 into 10. Solve this number directly to get the answer. This will come out to be 45 by 4, which will be 11.25 meters. Next is the time when the projectile reaches the highest point. Now, in the path of a projectile, do we understand? We have learned this in the last class, that at the highest point of the projectile, the motion of the projectile is just half finished. It takes half the time to reach the highest point and the remaining half to go down to the ground back. So can we say the time that the projectile takes to reach half the total motion will be just half of the total time of flight of the projectile? So this t that we are looking for will be nothing but the time of flight divided by 2. We know the formula for time of flight, it's 2u sine theta by g. So we have to just divide it by 2, which will give you u sine theta by g as the expression which we have to use. So u, which is 30, sine theta is 1 by 2 by 10. Solve this to get the answer as 3 by 2, that's 1.5 seconds, right? So simple questions, simple formula based question here. Let's move on to one more question. The next example is, it is given that the horizontal range of a projectile is 2 root 3 times its maximum height. We are supposed to find out the angle of projection of the projectile. So this is slightly trickier question where you directly have to work with the formulae and you have to connect them together to get the value of theta, though once you remember the formula it becomes quite simple. So Recall that the horizontal range is given by u squared sine 2 theta by g, and this is 2 root 3 times the maximum height, which is u squared sine squared theta by 2g, right. So, we just have to solve this equation now. So, many quantities will cancel out here. See that u squared will go away, g will go away, this 2 will also go away. Sine 2 theta on the left hand side, we can open up and write it as 2 sine theta cos theta, which is equal to root 3 times sine squared theta on the right hand side. 1 sine theta also cancels out, and we get 2 cos theta is equal to root 3 sine theta, which actually gives us tan theta, taking cos theta on the other side, is 2 by root 3. Now, since this is not a standard value of tan, we can write our answer here as theta is equal to tan inverse of 2 by root 3. This is how we can express the angle of projection in terms of tan. Okay, so this will be the final answer for this question. Let's take up one more example. The next question is, a batsman hits a cricket ball with a speed of 60 root 2 meters per second, and the angle of projection theta is given to be 45 degrees, and we are supposed to find out some quantities at a time of 3 seconds. Find the following at t is equal to 3 seconds. So, what are we supposed to find out? Number 1, the velocity of the ball. Number 2, the angle made by the velocity with the horizontal. So, let us call that angle as phi. Phi, the angle that the velocity makes with the horizontal, is what we are supposed to find. And number 3, we are supposed to find out the horizontal as well as the vertical displacements. All of these at t is equal to 3 seconds. Let us do that one by one. So, finding out the velocity first of all, for the first part, we know that the velocity vector, which we express as Vx I cap plus Vy j cap, where we now know from the knowledge of projectile, Vx is nothing but u cos theta. It does not change with time, it stays the same as the initial value of velocity along the horizontal, plus Vy, the vertical component, is u sin theta minus gt. And now we can substitute all the values to get this, right. So, u cos theta will be 60 root 2 into cos 45, which is 1 by root 2 I cap, plus u sin theta 60 root 2 into sin 45 is also 1 by root 2. So, this is the first part, minus g, which you can take as t times t, 3 seconds is the time. This all multiplied by j cap. Solve them. Root 2 cancels out to give you the velocity component along the x axis as 60 I cap, plus the next term will be 60 minus 30, or the 30 j cap. So, this is our velocity vector. Now, we see clearly here that 60 is the velocity component along the x direction and 30 is the velocity component along the y direction, right. From here now we can, if we want, we can find out the magnitude of this velocity also. What will be the magnitude? It will be root of 60 squared plus 30 squared, which if you take 30 outside of the square root 30, you will get a 2 squared plus 1 squared, which will be a root 5. So, 30 root 5 meters per second will be the magnitude, right. And the next part of the question now is to find out the angle that this velocity vector makes with the horizontal. So, once again let us draw the figure corresponding to this to understand this better. Vector v, let us say, makes an angle phi with the horizontal. In that case, we can connect the Vx component along the x direction and Vy with angle phi as tan phi is equal to Vy by Vx. That is, now we know the values. We know that Vy is 30, Vx is 60. So, Vy, which is 30, Vx, which is 60. So, this comes out to be 1 by 2, and hence we can write phi is equal to tan inverse of 1 by 2, right. the third part of the question, finding out the x and the y displacements of the projectile for the given u and theta. So, we can just use the expressions one by one. The x displacement of the projectile, if we recall, it is given by ux into t, the velocity of the projectile along the x direction times the time, because it is a uniform motion along the x axis, which is 60 as we have been given here, we have found it, into t, that is 3. So, this comes out to be a direct 180 meters. And the y coordinate comes out to be uyt plus half ayt squared, which is equal to u sin theta t minus half gt squared, and when we substitute these values, we will get 60 into root 2, which is the initial velocity along the y direction, right, into 1 by root 2, that is t, minus half g, which is 10, and t squared, which is 3 squared, and we just need to solve this now. So, root 2 cancels out, we get a 60 minus 90 by 2, that is, okay, there is a into 3 also here, the time multiplication is also there, into 3, so that makes it 180 minus 90 by 2, that is 45. So, 180 minus 45, which comes out to be 135 meters as the y displacement. So, we understand that after 3 seconds, the coordinates at which the projectile will be x comma y will be equal to 180 comma 135.